One of Scout's key features is its ability to quickly highlight N+1 queries in your application that you maybe weren't aware of, and then show you the exact line of code that you need to look at in order to start fixing that problem. In this video, we're going to look at a simple Ruby on Rails test application, but the same concepts apply to all the other major web frameworks too. So first of all, what is an N+1 query? When we talk about the N+1 problem, what we're referring to is the inefficient way of querying parent and its child data from the database, resulting in an unnecessary amount of individual calls to the database. A small inefficiency like this usually goes unnoticed when you're developing because you don't have much data in your database, but the moment you deploy and see this on real production data, the problem rears its ugly head. An N+1 is caused by the ORM layer of your web framework employing what's called lazy loading by default. And lazy loading basically means that for every child row that you try to pull data from, it's going to result in a separate individual call to the database. So in this case, you can see we've got 750 unnecessary calls to the database when we could have done that right at the start in one call. So if you know what you're looking for, an N+1 is actually quite easy to fix, but the hard part is actually finding them in the first place. So let's take a look at how you can do that with Scout. So, how can you use Scout to help you find N+1s in your application? Well, there's two main ways you can do that. First of all, let's imagine a scenario where you're investigating a particular endpoint and you're trying to find out why it's responding slowly. Let's say you've clicked on a trace and you've clicked through to the details of that trace, like I've done here. Now, as you can see, Scout does several things here with N+1s. First of all, it shows you this red N+1 logo to show you that this layer of the request generated an N+1. Next, it shows you that there were 200 unique calls to the database as a result of this layer. Then you've got a SQL button, which shows you the SQL that the ORM generated. And then finally, you've got a backtrace button. Now, if you have GitHub integration enabled, this backtrace button is going to show you the exact line of application code which caused the ORM to generate that inefficient SQL, and it's also going to tell you who wrote it to, which is useful. The other way of finding N+1s in Scout is using our N+1 Insights tab on the main page. This is a great place to start if you're using Scout for the first time, because without diving into individual traces, it's just going to pluck out all the N+1s that we found and give you a quick link to investigate them. So now that we've used Scout to identify an N+1, let's go ahead and fix it. Here we've got the index action of the articles controller, and as you can see, the user browsed to the index page, Rails routed that to the index action of the articles controller, the index action then rendered a template, and in that view template we had two SQL statements which executed. First of all, we selected everything from articles, and then we selected everything from users matching on user ID. Now this is where the N+1 happened, so let's take a look at the backtrace. As you can see, this is the exact line of code which we wrote, which caused the ORM to generate this poor SQL. So what's happening is for every iteration of the articles loop, we're doing article.user.name, which is fine because the user table is a child table to the article table, so that shouldn't be a problem. But with lazy loading employed, what's going to happen is a separate SQL statement is going to be created and a separate query to the database is going to happen for every iteration of that loop. That's obviously not what we want, and that's what's causing this poor response time. So what we need to do is we need to change how we load the articles instance variable to instead use eager loading and specify that we also want to load the user table as well ahead of time. So let's go ahead and do that. Here we've got the index template, and line 20 is that call to the user.name child data. The articles instance variable itself is loaded in the index action of the articles controller, and all we're doing is articles equals article.all. So if we want to use eager loading instead, all we need to do is add a call to includes and specify the user table. And that's it. What this is going to do is it's going to create a much nicer trace for us, which has one simple SQL call, select everything from articles, select everything from users that matches on that user ID, and do it in a single transaction. So we've reduced the time from over 2 seconds to 261 milliseconds. The important thing to know about N+1s is that fixing them is quite trivial. The difficulty is actually finding them in the first place. And as you can see, Scout has got you covered there. Finding N+1s in Scout is fast, easy and painless. If you're not already using Scout, then why not find out how easy it is yourself and start your free 14-day trial and find and fix your first N+1 today.